All right, so today I want to talk to you about how to find the area of a regular polygon. So a regular polygon means a polygon whose sides and angles are the same. And you could always put a regular polygon inscribed inside of a circle. So there's some parts of a regular polygon that we need to discuss. Let me reinforce that this only works with a regular polygon. A regular polygon will have a center because if I inscribe it inside of a circle, that circle has the center, and the center of the regular polygon is the same as the center of the circle it would be inscribed in. Now, we don't normally talk about polygons having radii, but a regular polygon will have a radius. And that distance is from the center to a corner. So that's what I mean when I'm talking about a radius. And then I'm going to give you a brand new word. Apothem. Apothem is one of those little animals that pretends like it's dead and you don't think it's dead, and so you leave. No, I'm kidding. An apothem is the distance from the center perpendicular to a side. In a regular figure, the apothem will bisect the triangle will be the perpendicular bisector of the triangle formed by two adjacent radii, because if you're using the same length, which radii will always be, to form two sides of the triangle, it's automatically isosceles. And the perpendicular bisector of an isosceles triangle is its altitude, which is the apothem. Apothem, apothem, apothem. I love that word. It's impossible.
I had a possum once.
Sad story. Probably true.
Well, it was already dead, but I just ran over it.
All right, so make sure you know how to identify a radius in a polygon, and make sure you know how to identify the apothem. The other thing we're going to be doing is we're going to be coming up with some techniques to solve all the angle measures inside a regular figure. So what have I done here? I've drawn the four radii inside this pentagon, and I've also drawn one of the apothems. And just knowing that it's a regular figure and just knowing how many sides it has, we should be able to figure out all of the other angles of this figure. So how would you do that? Well, let's think for a second. If I go all the way around in a circle, how many degrees did I just travel? 360. That's a pretty common term. People talk about doing a 360 when they completely turn themselves around and they wind up back where they started. Half of that would be a 180 when you're going in the opposite direction. Oh, I need to do a 180. It means turn around and go the opposite way. So if there's 360 degrees in the circle, if I draw a circle right here, how many angles did I go through? 1, 2, 3, 4, 5. I would say 5. Are y'all comfortable with that? If I have more sides in my figure, I'll have more radii, and I'll have more angles that I go through. So this number will change depending on the sides of your figure. So what I'm saying is that the measure of angle 3 and the measure of angle 1 is based off of knowing how many sides you have. It's 360 degrees divided by the number of sides. So you will always find that whole angle by 360 divided by n. In this case, 360 divided by n is 72 degrees. So angle 1 and angle 3 are 72 degrees. But that's not all. In a triangle, if one of my angles is 72 degrees, how much would the other angles have to add up to be?
180.
Well, no. 180 minus, I'm already considering a 72 degree angle. So what's 180 minus 72? Huh?
108.
108. So whatever this angle is right here, and whatever this angle is right here, it has to add up to be 108, right? Because I've only got 108 degrees left, and these two angles have to make up that. However, if they're both the same, and why would they be the same? Because these are both radii and they're congruent. This is an isosceles triangle. What would these two things be? 54. So these inside angles are half of the supplement of these top angles. And if I told you that this was a perpendicular bisector, and this whole angle was 72, what would 4 be? 36. So see, we just identified angle 2, angle 1, angle 3, and angle 4. And all we knew was that it was a regular 5-sided figure. That is going to be crucial and key to be able to do that. Most importantly, we're going to need to know very detailed what angles fall in this area right here. These are the important ones to find, but you should be able to find all of them. Any questions about what I just did there? All right. So what I'm going to do now is I'm going to give you an octagon. So in an octagon, what does n equal? 8. And I want you to find these measures. So I'll blow that up a little bit. So just looking at that portion of the octagon, I want you to find, I'll even swirl it around a little bit so it's a little bit more basy. I want you to find the angle between the radius and the apothem. I want you to find the angle between the radius and the base, and I want you to find the angle between two radii. By the way, the angle between the two radii is where you should start, and then angle 2 will be half of whatever 1 is, and then angle 3 will be half of the supplement of angle 2. Or actually, you could just do angle 2 plus angle 3 plus 90. See if you can't find those three angles, because it's crucial that if I give you a number of sides, you be able to figure out what these angles are. And in an octagon, they don't come out very pretty. So if you get some strange answers, don't worry about it. That doesn't mean you're doing it wrong. Go ahead and work on that with your partner. All right, let's take a look at how we would solve that. Remember, in an octagon, you have 8 sides. Angle 1 is going to be representative of 8 different angles that exist in a 360-degree circle. So angle 1 will equal 360 divided by 8 because it was an octagon. So 360 divided by 8
45.
comes out to be 45. Since this whole angle would also be 45, and 2 is one of the bisecteds, the measure of angle 2 is going to equal half of that. 45 halves, or unfortunately that comes out to be 22.5. And then 22.5 plus 90 plus 3 is equal to 180. You could just subtract 22.5 from 90 to get angle 3, because these two have to be complementary since they have to add up to be 90. So the measure of angle 3 is equal to 90 minus 22.5, which would be 67.5. So the point I'm trying to make with this exercise right here is whether you know it's an 8-sided regular figure or whether you know it's a 5-sided regular figure, you ought to be able to find out this angle right here and this angle right here, just by knowing how many sides it has. And just about every problem we work will tell you how many sides there are. And then you got to find out the area. Find out the area? That's crazy, Mr. Baker, you might be thinking. Well, in actuality, there's a formula for finding the area of a regular figure. The formula is based on this thing. Area is equal to 1/2 AP. And A stands for that new word we just learned, apothem. And P stands for a word we should already know, perimeter. By the way, the perimeter is equal to N times side length inside a regular figure. Because if I know the length of one side and all the sides are the same, I just have to multiply that one length by how many of them there are. Right, you see? You with me? All right, so this is the formula. I think this formula is on your formula sheet.
Are all these on our formula sheet?
Huh?
Are all these on our formula? No.
This is the only formula we have for this unit.
Mr. Baker, do you do N as just the one to the bottom half, or like the entire thing? It's like on the
N
bottom
is the number of sides inside your figure.
Okay.
N is so even if I don't show all the sides, N is representative of how many sides it has.
So if it's an octagon, it'd be 8.
Right. And if it's a decagon, it's 10. If it's a square, it's 4.
14 gone.
If it's a 14gon, it's 14.
Will you be, put one like that on our first one?
A 14gon? No.
No,
Just divide by
like
14,
one of
if
those
anything,
with
you
like
don't
9
even have to
sides
guess
that
the
none of us
number.
know.
Nonagon?
Yeah.
I might.
It's
All right.
It's really not that hard.
Let's take a look at the area of a regular decagon. Oh, this is so nice. They have given me this value right here, which is what? But what is it?
The apothegm.
The apothegm. And this is what? What part of the figure is it?
It's part of the perimeter.
It's part of the perimeter. It's one of the sides. So in my formula, area is equal to 1/2 apothegm times perimeter. We now have all the numbers we need to just plug it right in and solve it. I'm going to do 1/2. The apothegm was 12.3. The perimeter is going to be equal to 8 times 10. The number of sides times the side length. So this right here is P. Yeah, so we're just going to plug that in the calculator. You know what? When I'm plugging stuff in the calculator, you know what I use for 1/2 a lot? I do, 0.5. So 0.5 times 12.3 times 8 times 10. And I get 492. And my units are inches, so the area would be square inches. Everybody okay with that? Let's practice one. Find the area of a regular pentagon with 8 centimeter apothegm and 11.6 centimeter sides. The formula is area is equal to 1/2 the apothegm times the perimeter. What was the apothegm? 8. Well, and how do I find the perimeter?
You do 11.6. Whatever. Is it 5?
Yeah, pentagon is 5. So 11.6 times 5. Yes, you do. So 0.5 times 8 times 11.6 times 5, and I get 232. So the area is 232 square centimeters.
Is there ever going to be a time where like the apothegm is X?
Well, it's
So
gonna be the area.
there might be some times when you don't know all of the information, such as the apothegm. So let's take a look at this word problem, and then I'll sketch it out, and we'll do some stuff. So a honeycomb is made up of regular hexagonal cells. So I'm going to draw a regular hexagon. Actually, I'm not going to draw a regular hexagon. I'm going to use the Active Inspire tool to make a regular hexagon. I'm going to make it really big. And so I know that the length of one of the sides is 3 millimeters. And I need to find the area. And that's all the information I'm given. So here's where that stuff becomes important. If I know the center, and I know the angle of the radius, and I know the angle of the other radius, what's this angle right in here? It would be 360 divided by 6, because there's 6 sides and 360 degrees all the way around. What is 360 divided by 6? 60. And then if I drop the apothegm, which is what I need to find the area, half of 60 is what?
30.
30. Oh my gosh, what kind of triangle did I just make?
90.
A 30, 60, 90. And the apothem is the longer leg of that. If I just knew how to find the shorter leg, I would be in business. Does anybody have any idea what that shorter leg might be? Why?
Because you're gonna do that divided by 2 because it bisects it.
Right, it's 1.5. So A is going to equal 1.5 times the square root of 3. So I now have the apothem, 1.5 root 3. I have the side length, which is equal to 3. I can find the perimeter by multiplying the side length times the number of sides. So the perimeter is going to be 15. So area is equal to 1/2, 1.5 root 3 times 15, the perimeter, or 5 times 3.
Why would you do 5 times 3?
Because there's 5 sides. Oh, I stand corrected.
I was a little confused.
You are correct. I am incorrect. All right, so now it's going to be 0.5 times 1.5 root 3 times 18, and I'm going to round off to the nearest whole tenth. I'm going to round off to the nearest whole number. No, I'm going to round off to the nearest whole number. So that's about 234 square millimeters. Is everybody okay with that? That's how much area it is. All right, so basically what I'm saying is, tonight on your homework, there are 3 types of figures that make the special right triangles when you do the apothem and the radius. And they are, and this is what you need to be working with, they are a hexagon, a square, and an equilateral triangle. So if I were to go and mark the centers in all of these figures right here, and then I were to go and find the radii, with the apothem, in a hexagon, that's going to make a 30, 60, 90 triangle with the 30 degrees at the top. So half of this side length is the shorter leg. However, in a square, what kind of angles are we going to have? 45, 45, 90. So now half of this side length is a leg, and so it's going to match this value. And in a triangle, where you have the apothem and you have the radius, now it's still going to be a 30, 60, 90 triangle, but now the 60 degrees is between the apothem and the radius instead of between the side and the radius. So it changes this from a shorter leg to a longer leg.
How many questions like this will we have?
I don't know. Enough that you need to know this stuff. All right, so let's look at this problem and let's just figure out what the apothem would be based on 16 feet for each of these situations right here. So if I tell you have a hexagon with a side of 16 feet, how much is this right here?
8.
And so what would that make the apothem if this is the shorter leg? 8 root 3. So if you know the apothem and you know the side, you can put it in the formula and solve. I think everybody can do that. All right, if it's a square and this is 16, what's the apothem going to be?
8.
Right, because this length right here will be 8, and legs are the same in a 45-45. if we're doing the equilateral triangle, and this is 16? What's the apothem going to be? A little bit trickier. Don't simplify it.
8 over root 3.
8 over root 3. Because half is 8, and to go from the longer leg to the shorter leg is 8 divided by root 3.
What if it just gives you the radius?
If it gives you the radius, then you've got a side of the triangle, and you can use the special rules to find the missing value. So you'll need the apothem, but then you'll also need this length because you have to double it to get what the side is. So that's a great question. If I gave you that, let's do the square because the square is the easiest one mathematically.
Yeah, if it was like 6 or like 7.
Yeah, let's say that this is 7 root 2. Okay, what's this going to be?
7 root 2 over
7 root 2 over root 2, which is 7. And then what would this be? So this would be what? 14. Does that make sense? Okay, so I could give you the radius of the figure, I could give you the apothem of the figure, or I could give you the side length of the figure, and you've got enough information, if it's one of these special cases, to solve for the area for the whole thing.
Wait, how did you get the apothem? Like, what's the formula? So, like, if you have.
So it's a 45, 45, 90, and we have the hypotenuse, and a leg is equal to the hypotenuse divided by the square root of 2.
So the leg is the hypotenuse.
Yeah, it's your 45, 45, 90 triangle rules.
Okay, that's fine.
All right, there's your homework.